Thanks everyone for joining. My name is Jack Pearson. I'm the OA director at Opteran. Opteran is developing autonomy software for mobile robots by reverse engineering algorithms from brains. So today we will be exploring the challenges and pain points of mobile robot autonomy in warehouses and really discovering the hidden costs that are blocking profitability. So before we get into intros, I think it might be useful to give some context as to why we chose this topic. It's been really interesting. We've been traveling around the world, speaking to people who are building mobile robots, and it's become really clear that many people are facing the same challenges. The industry is really trying hard to move away from infrastructure-based technologies for mapping and localization, things like magnetic tape, Aruka markers, trying to move towards things that are more flexible, like SLAM. The challenge that we're seeing, though, is that SLAM can often have many hidden costs, driven by complexity, but also by challenging development, setup, and management requirements. And what we found quite consistently is manufacturers tend to focus a lot on the bill of material costs when picking autonomy approaches, and maybe less aware of other costs that have a big impact on overall profitability. So today, with the help of our esteemed and very experienced panel, I think we'd love to learn more about these impacts and dig into total cost of ownership and the impact it can have on building and managing autonomous systems in warehouses. So without further ado, it would be fantastic if the panel could introduce yourselves. Maybe we could start Garret, Javier, and Michael, and it'd be great to hear from you.
Yeah, thank you very much, Jack. Thank you for the invite. My name is Garret Place. I work at IFM Electronic, and my background is in robotic perception.
So,
my name is...
no, you go.
Oh, okay. No, Martin, please.
All right.
Sure.
Well, thanks for having me. I'm Michael Martin from SAFELOG, one of the main suppliers for mobile robots within Europe. I'm a partner manager, being mainly responsible for building integrator partners, bringing our robots into the rest of the world out of the regions we supply with our own teams. So, yeah, it'll be an interesting discussion.
My name is Javier Miguélez. Thanks, Jack, for the invite. I am co-founder at the Mobile Robot Directory, which is, I think, right now kind of a Bible where you can find any kind of mobile robotics provider. And I work in moving robots as well as mobile robotics consultant. I've been already working for the mobile robotics industry for the last 11 years already, which is quite a lot in this industry, to be honest.
Thanks all. We really appreciate you joining us and super excited for the conversation. So I'll be moderating and facilitating, but let's have an open conversation. Feel free to jump in with any questions or comments, and we don't need to be too prescriptive. So before we start jumping into the conversation, we're just going to throw up a little poll of 2 questions, I think, just to gather some info from the audience, because I know we're going to have some really interesting insights from them as well. We'll give everyone a second to answer that. So I think it'd be really interesting to start off by exploring the broad challenges of mobile robot autonomy. So Javier, you mentioned mobile robot directory. You've got a huge bird's eye view of the industry. It'd be really interesting to get your take on some of the main challenges around autonomous navigation in warehouses today.
For me, the challenge is not in the autonomous navigation itself. So I think the localization technologies that we can find in the market, well, there are so many, and well, you can easily find a technology that fits your needs and the needs of the end user. I think that the challenges that you can find are more related to the time it takes until you have deployed the mobile robotics fleet, AGV or AMR fleet. So the time it takes and the skills that you need for that. So ideally, what our customers or end users, mobile robotics end users would like is that the installation is done really fast, and the skills that you need are really low. This is like, I always talk about the Roomba, that cleaning robot that we have at home. So easy to install, and you don't need to be a genius to install it. So this is the same thing that the industrial mobile robotics end users need and require from the mobile robotics industry. And there is a clear difficulty there.
If I'm hearing you right,
I guess that Martin knows a little bit about that.
yeah.
Customers always push.
So if I'm hearing you right, once the navigation is set up, it's fine, but it's actually the setup, skill, and time that has a huge impact.
For sure, you have to choose the correct localization technology, but once that you have chosen it and it is the correct one, the difficulty comes when you have to install the project. Imagine even that you have to install 1,000 projects a year. So the scalability for that business is extremely difficult.
Garret, I can see you nodding along there.
Yeah, I agree with Javier on this. It's a lot of the soft costs that are involved in the initial setup and installation of these systems in a warehouse facility or in a manufacturing facility dramatically drive up the costs. But I think also for OEMs building robots like SAFELOG, you have additional soft costs of those, let's say, highly skilled engineers that have to follow the robots to site in order to get them set up. Those highly skilled engineers are now not available to do the next projects or the next R&D that you need to do in order to keep pace with the market. And I think, in order for the market to scale, we really need to find a way to not only, to Javier's point, dramatically reduce the setup complexity, but also make it easy enough where not only can we have installers go out and install these systems in the facility, but also have installers available to maintain these systems. So the degreed engineers can go on and do what they're supposed to do.
Yeah, that's an interesting point. So it sounds like there's agreement around the setup of systems, but I think pulling on a thread that you mentioned earlier, Javier, does it not really depend on the technology itself? Michael, it'd be very interesting to understand your view. I know SAFELOG uses a range of different localization technologies. How do you think about the trade-offs in selecting different technologies and where they're applicable?
So I totally agree with the others. It's the challenge is, or the trick is, to combine the different technologies, right? Because one has a benefit in like type 1 area, right? And the other one is really has really high problems with, say, other means of transports, for example. Like the most classic way of like magnetic tape hates forklift wheels, right? Of course. And the classic LiDAR scanner has a problem with glass and curtains, etc. So to combine them individually, however, right now takes some skill set, right? You need those engineers on the shop floor, like Javier mentioned, to decide which one to take, right? In the end, you'll have a robust solution. However, you lose in flexibility if you do have to combine it in a, say, complicated way, because your environment is very, very complex.
So it sounds like, yeah, so the selection is very important. Out of interest, how often do you need to have multiple approaches to get a solution that actually meets customers' requirements robustly?
We always combine them from the start. Technically, well, how often is a hard question. It really depends on the industry as well. So some industries don't even require that flexibility, right? A classic warehouse and a shelf-to-person system doesn't require it. Whereas in the automotive industry, it's a completely different setup when things change every couple of months even, right? So we always combine it out of robustness. In the end, the process has to be simple. It has to be, well, easy to understand for the local maintenance on site. And yeah, that's in order to do that, you want to use as little technologies as you can, especially with like say not complex sensors, etc., right? Something they can understand on site without a lot of training, without being the expert.
That's a very interesting approach. Javier, Garrett, it'd be interesting to get your takes. How often do other OEMs like combining? Because I mean, the sense that we've gotten is that people in many situations are trying to move away from infrastructure towards something that's more flexible and doesn't require, you know, physical additions to the environment. Are you seeing that many people are actually combining the two approaches?
Yeah, I think tough question to answer specifically. So maybe just some general statements to that point. First, we are not seeing, to Michael's point, 10, 15 years ago, manufacturing was very static. You did the same thing for months and months and months, maybe even years, as you produced products the same way. That's shifting. And now we see a high mix, high volume type approach to manufacturing that requires a lot of change month to month, year to year. And that is putting a stress on the traditional modalities for localization that make it hard just to choose one, right? But on the other side, we're getting a pressure on, keeping reducing friction for installation, reducing friction in production, as well as maintaining these systems and overall cost. So even though we want to talk about the total cost of ownership and reducing it, and to Javier's point, reducing, let's say, a 1 month install to 1 week, we also need to understand that we have to maintain and keep a visual on overall cost of the BOM, what that robot cost is. And I think that's where companies are struggling today, is maybe a little bit too much focus on BOM, which is reducing the implementation of a multimodal system for localization.
I'm going to come back to that point in a second, Garrett. Javier, I saw that you wanted to jump in. Have you got a view you want to add?
Yeah, what I just wanted to add.
Oh, you're a bit
So
jittery, Javier.
in
So
the
we
end,
can't quite hear
we
you.
have seen during, quite, sorry?
Oh, sorry, there was a bit of a delay there. Maybe it's better. We may have lost Javier. So,
Hello?
is there a bit of a delay on your end? Sorry.
Hello?
Seems to be back. Sorry, continue, Javier.
Yeah, I was saying that so what we have seen for the last 5 to 10 years is that there is an evolution in the technology that we are using in this industry, but this mainly comes from the end users. So they are pushing us to have technologies that need no references on the floor, no references on the walls, but they have not really focused, the end users have not really focused on how much time it takes to deploy a mobile robot with X technology. So what I am trying to say is that it is easier for end users to focus on what technology are you using than how fast you are in case that you need to do this installation, or how fast you are in case that that I need to make a modification. So they do not ask that. Why? Because, well, they are ignorant, let's say so. They have very, well, the knowledge that they have about mobile robotics and how mobile robotics works, it's really low. Actually, the thing is that if you, coming back to the Roomba again, if you have a look at the Roomba, it is so fast to install. If it would take you 1 week to install it, nobody will use it. So for them, it's quite clear that that's a key point. So we don't really care as users what technology the Roomba is using for localization. We don't care. What we want is that it cleans and a fast installation. But until now, end users have not focused on that.
So just to clarify that, that's really interesting. So you're saying there's a driving force from end users. They're asking for specific technologies without knowing exactly what they're asking for rather than focusing on the value that they need, i.e.
Exactly.
setup time, management effort. Is that the crux of it?
Exactly. That's my point of view.
That's interesting.
I think that's a bit like the result of, say, trade fair fakes a little bit. Like there's a lot out there, a lot of technologies out there that just advert their technology without like really having shop floor experience or being out there or knowing what's actually the result of using that technology. So I'm a massive fan of keep it simple, right?
I agree.
Sometimes, like literally, not want to going too much into magnetic tape, but literally, if you have a loop where there's no forklift or nothing else, and the unit will drive in a circle for the rest of its life, stick a piece of magnetic tape, and every maintenance guy can change it or change the course or do whatever they want within a matter of seconds. And the level of training you need to change magnetic tape is basically zero. However, like you lose a lot of flexibility, a lot of things don't work. Like, and to be honest, in a real project, this ideal situation is not like that. And we should focus on the benefit of why people use mobile robots, and that's because of flexibility, right? That's because of that point Garret mentioned, which brings us back to the system has to be as simple as changing magnetic tape, but maybe not physically.
Yeah, I can completely agree, Michael. It's and I can always I struggle with this word obfuscate the raw technology, right, and simplify the approach. And because at the end of the day, when these companies are bringing robots in, they're bringing robots in because of a labor shortage, and they want to provide a certain level of certainty of labor to their facility. And so robotics help you provide that certainty of labor, but we haven't seen that mass crossover yet or that mass adoption yet because the robots are still overall somewhat expensive to provide to the end user. That's BOM cost, install cost, maintenance cost, but also they're still complex. And so how do we continue to drive down the complexity of these systems without reducing the overall efficiency of the system?
That's really interesting. I think it'd be great to move on to a kind of cost perspective, but kind of mirroring back what I've heard, it sounds like the technology lens is almost the wrong lens. The end user needs to be clear on the specific value, and then it's the role of different people in the industry to figure out what the best technology is for that specific use case. So I want to pick back up on a point that you mentioned earlier, Garret, around the fact that companies seem to be very focused on bill of material costs. I'm wondering from your perspective, are there any other common misconceptions around mobile robot costs? And do you have a view as why there's such a focus on bill of materials over other costs?
Yeah, it's again, another complex question to answer, right? But I'll take my best stab. I think concentrating on a BOM cost, we all have to be aware of how much the unit costs, right? There is a inflection point on cost of robot versus the value it provides to the end user. And we can't be on the wrong side of that inflection point. That said, if I can add, let's say 20% efficiency by adding 10% to the BOM costs, that efficiency gain that you have with that robot dramatically overcomes the 10% adder in BOM costs. For example, if I have to move 10,000 pallet loads a day, if today it costs me or it takes 80 vehicles to maintain that throughput, if I can provide a more efficient robot that allows you to do it with 60 robots, I've now dramatically reduced my overall cost of that install, both in maintenance time, installation time, long-term or longevity in application. That efficiency gain probably comes at a cost of BOM. But if we're only concentrating on BOM, then we'll overlook the efficiency gain.
That's really interesting. I mean, it's obviously there's many technologies, it's a very complex industry. I'd love to get some examples of unexpected expenses. If you've got any anecdotes or specific stories where, maybe costs haven't been what a customer expected. I think that could be really interesting. Javier, you see
I think that the most the unexpected costs usually you can find them during the installation of the mobile robot. I always talk about the unexpected pillar. So you have a loop, just like an easy loop from point A to point B. The customer has shared with you the drawing, and everything seems to work fine. You arrive to these new facilities of your customer to install the mobile robot, and suddenly you realize that there is a pillar, just so that the AGV cannot drive through the pillar, and this is very, very common. So there is a difference between the paper and the reality, and in any mobile robotics project, you will always find a difference between the paper and the reality, and you need to adapt. And yeah, for sure, maybe the responsibility comes from the customer, but you need to install that AGV as soon as possible because you have to go to the next installation. So, okay, that's like a hidden cost, but it's very difficult to solve that situation because most probably you need more time to make that deployment. But first, who's going to pay for that, and who's going to pay the opportunity cost of taking more time for that project? And for me, that's one of the most difficult parts in mobile robotics, in a mobile robotics project. You can't never be sure about what's going to come. There are always some uncertainties, particularly because this is a mobile robot. It's moving, so you never know.
Yeah.
Sometimes it is 1%, sometimes it's 50%, sometimes it's just in between. You never know. There are some tips there, but well.
I see you nodding along, Michael. Have you got some anecdotes you can share, or how does SAFELOG get through that challenging uncertainty?
It's very, very true what Javier says. There is a reason, why we only send a quotation to a customer after we've been on site, simply because it's mobile, right? Even when you start the installation, there is a risk, right? There is a complexity there. It's not a static thing we can build up in our own shop floor and then just copy paste it somewhere else, right? Because the environment is different. The trick is to cope with the environments, and it's often, if it's really about hidden cost, if it's often or unexpected cost, it's often the things that's about the infrastructure in their shop floor. So that might start with a fire gate which is not connected to your network. Suddenly you have to install some simple I/O module to it, right? But if it's not just one gate, or if it's not just one sensor, you suddenly have to put different sensors throughout your production to somehow give that monitoring, which used to be done by the forklift or tugger train operator, looking around and seeing a bin is empty. He suddenly has to, that information has to be in the system, right? That has to kind of be optimized. And if you just compare, and that's a classic thing, you compare tugger train plus operator cost against mobile robot, and it's totally forgotten that somehow that signal, that empty bin, that pallet to be moved, that gate has to be controlled. All those things, if they're not in the system, they have to be installed later on. So that's, say, unexpected. We know that, of course, before the project is offered, but at the very first discussions, customers tend to forget how orders are created, how the whole setup is moving.
One thing you almost have to become an expert. Oh, sorry, Jack.
No, go on, Garret. Please.
You almost have to become an expert in the way the customer is managing their business and their process flow just to install. And it brought a thought to mind. Every one of these installations is essentially bespoke. It's a brand new, even though it might be the same robot type. Every facility is different. Every process is different. And so every time we go out to install a robot, it's a new project. It's not just rinse and repeat from the last, even inside the same end user. So
Right.
There's a lot of effort there. I think one of the things that's coming in the future, and this may be a topic for later, which is a lot more simulation in the robot side. So can we simulate enough, because it will never be perfect, but enough to reduce the overall install time by X%?
That's interesting. So what I'm hearing is that the costs of setup, at least, is unexpected for end users, but for OEMs, it may be expected, but it's still very unpredictable because of the level of bespokeness required.
You have to be on site at least.
Mhm.
And sometimes you have to have your device on site.
One of the things I find interesting, though, is that even in speaking to, really experienced OEMs and end users, they don't seem to have great numbers or a great understanding of the actual costs or even the range of costs that can happen. It just seems to be a bit of a black box that can only be solved by going on site and doing a specific inspection. That's quite a lot of fixed upfront work before actually implementing. Is there anything that we can do about that, or do the current technologies just require that consultancy aspect?
Well, I always say that there is a rule. I think I don't know if they use it at SAFELOG, but I have been using it for the last 10 years, and something that you can use anyway. It doesn't happen 100% of the times, but 95% of the times it works. So 2/3 of the total amount of the project are AGVs and AMRs. 1/3 is the rest, and that includes software and installation. It works 95% of the cases, not just with one mobile board, more than one mobile board, but it always works. If you think so, if you're quoting your project and you see that the installation and software cost is less than 100, man, you get a problem. So this is like a tip that you can use. Always 2/3, 1/3.
This sounds interesting. Can you reiterate that? So if I'm hearing you correctly, 2/3 of the cost is the hardware cost for the AGVs, and then a third of the cost is everything else.
Everything else, exactly. So if your numbers do not match that, you have a problem. You are missing something.
And what was that point about under 100K? Are you saying if the third is less?
It has to be more than one mobile robot. It
Okay.
doesn't work for one mobile robot usually, because the amount of software that you need for one mobile robot is, well, from a percentage perspective, is much higher. But for more than one mobile robot, it works.
Okay.
And I have tested this rule with many different providers, and it works.
That's
Can
a
I
great tip.
can I comment that?
Yeah, sure.
I think it's a bit different because, and that really depends on the type of project you do. We do projects, unbelievably complex projects with 5 units. You have 300 handover stations. You have like a really complex setup, maybe with a custom like shop floor management system on top, integrating to the ERP system, etc. Like even left that aside, if you do that with 3 or 5 robots, it's a crazy amount of work for the actual transports you do. However, we have on the other side, we have projects with, say, multiple hundred units in one shop floor driving in a loop. So, and sometimes the complexity of 100 units driving in a loop is less than 5 units driving in a complex environment. And that's simply because of the process behind it, right? Because you do have to, and that's back to the localization topic, you do have to map, say, 100 square meters of areas and or to like set the localization for the robot, and that map can be used by 100 robots or by 5. That's completely not connected to each other. Like the number of robots has nothing to do with the installation cost in my eyes.
I am saying that it doesn't. I was saying that it works 90%, 95%.
Okay. Because most of the
Always.
projects have the same size, right? I
always.
agree with you, but there's a
always.
big gap.
There are
Yeah.
outliers. I can. That's an interesting point. It's an interesting rule of thumb. If we look at that third, the rest, and break that out, what percentage do you think? What are the cost components of that? There's obviously, setup labor. What else is in that gap that you think is important? What are the most important ones?
Software and installation, and software and installation, and then maintenance goes completely separated from that. But I would say software, so software licenses, so on, and then the installation, including the installation, all the project management and so on. Right?
Right. Garrett, I know IFM likes to think about total cost of ownership. I know you have calculators as examples on your website. I'm curious, what else can suppliers and OEMs be doing to help end users make these decisions?
Yeah, it's a good question. And, kind of jumping on the comments from Michael and Javier, there's in this 1/3, I think one of the things that, and Jack, you and I have talked about this many times about the amount of labor it takes in order to install these systems. And Michael, I love your concept of a 5-vehicle install might be much more complex than a 300-vehicle install, just purely based on the use case that it's trying to solve. And I think one of the things that we overlook a lot in these systems, talking about software licensing, install costs, things like that, is the actual labor cost that it takes to do so. And so each time you're out, if you have a 3-week install, that's 3 weeks of hotels, 3 weeks of per diems, 3 weeks of people out on the road trying to install the system, but it's also 3 weeks of disruption in the plant. If we're all doing greenfield, it's fantastic because there is no disruption. You're just doing your work. But a lot of these installs are brownfield. And as soon as you start having a team of people trying to install a robot fleet, you start to even just emotionally disrupt the facility. And those costs, I mean, per diem, hotel costs are manageable, you can document them, but the disruption cost is hard to define. But I think a factor in people making a decision to deploy mobile robots.
That's really interesting. It'd be good to move on to the future and thinking about how you guys think the industry is going to change. It sounds like, from our perspective, OEMs are very interested in reducing sensor costs, reducing infrastructure costs, even in reducing or increasing robustness of technology, so there are fewer call outs. But it seems like setup time is not a big area of focus. But from this conversation, that seems to be one of the most important aspects of the hidden costs. With that in mind, it'd be great to get your takes on where do you think the future of these technologies lies, the future of mapping and localization for mobile robots? Where's the industry going?
So first of all, I'm sure the industry will move from being an innovation where we are right now. It's still an innovation, right, to being a normal thing to do. Nowadays it's normal to have a phone, right? Everyone has a phone, right? It wasn't always like that, right? And it's the same thing. You don't need to do that simple operations. We need those people in different positions, like driving a forklift, just driving it around, right? Stacking is a different topic sometimes, but so that the whole industry can move to a real serial setup. And saying that, like to Javier's Roomba example, right? Roombas is a normal thing to have. And why is that? It's simple. Everyone can use it. I don't have to have like a complex team somewhere, right? It has to be intuitive to install. We see a lot of customers ready to have their own expert team to install their own systems. So they don't want us to do the installation anymore, or not the serial part, maybe just a bit of training or the really complex part. So if it's intuitive enough, flexible enough, and the requirements, the skill requirements are low enough, and that's, I'm looking at the industry right now where it's moving, you won't need to have that time anymore. And all that with for the price of a Roomba, right? At a low cost, right? The sensors, you can't install 10, 20,000 euros worth of sensor equipment in every robot, because first of all, the costs at the beginning, but second, every sensor will break eventually or might break eventually. So it's back to maintenance costs, and it's back to like hidden costs, etc. So it must be simple, it must be intuitive, and yeah, I think we're in a good way there.
I couldn't agree more, Michael. And I like Javier the Roomba example because it's one that I land on often as well. we have to get to this point in minimizing the complexity of these technologies for the end user to allow them, as Michael said, to install their own systems. So we don't have to go out and be the expert to install. It has to be quick, easy, simple. I see more specialization in these robots. So you can deploy the robot for exactly what it's meant to be, like a Roomba. And Roomba vacuums floors. That's all it does. And it's got to be, we have to get to that point where this complexity is truly minimized in this industry. I mean, today we haven't reached an inflection point. We'll get there. You know, the labor shortage and the requirement for a certainty of labor is going to drive everyone towards automating in their facilities. But right now we're stuck at that high level. And we need to reduce that to get to that mid SME level, which is the majority of the manufacturers today. Majority of logistics are at the SME level, not at the Fortune 100 or 500. And until we drive out the complexity of these systems, we're still going to have that blocking point in there. And I think, I mean, getting back to localization, right? The way I view localization, even if I have to add a small amount of features, codes, fiducials, whatever they may be, that adds complexity both in the install and it adds complexity in the maintenance of those systems. And so I see localization driving towards complete infrastructure freedom without any requirement to manage that system and maintain good localization over time. That's got to be the way, because otherwise you need experts to go in and map your facility in order to know where to put the fiducials.
Javier?
Well, so I think that we can discuss about this topic for hours, but going straight to the point, first regarding the technologies that we are going to use, particularly for localization, I think we will see, well, it's what Garret has mentioned before. It will become more and more, well, it will become easier and easier to deploy AGVs and AMRs, and for sure that's clear. And I think that in a couple of years we'll see that 3D SLAM will be coming to save our lives, but it's not really saving our lives as long as the software that manages those mobile robots is clearly user-friendly and easy and fast. So that's regarding the localization technologies and so on. Regarding the installation, I can agree with Garret that we will see some digital twins working there. And then regarding the maintenance, where I see that, so I don't think that people right now focus that much on the after sales part of the AGVs and AMRs, but I think it's going to be key. Why? Because of the availability. So it's nice that we have Garret here, in fact, because actually IFM is providing one of the best devices or PLCs for AGVs and AMRs. They are really easy to substitute, and they don't give any problem. They are really prepared for vehicles. And OEMs, I think, regarding the BOM, OEMs will be focusing more on the after-sales problems that you may have than on other things in the coming future.
That's really interesting. What I'm hearing, recurring theme here is ease of use and simplicity. You know, so easy that even the end user can set it up and manage it. That seems to be the
so easy and no problems. That's where everybody
no
goes.
problems. Yeah.
So easy, no problem. So easy.
Especially
no
number two.
Yeah, it's
I really agree. First, no problems, and then so easy.
Well, they will always only say easy, but once you have the first problem, they'll switch their opinion. But yeah.
Easy,
it can't be a black box either.
And cheap. Those four things in the end.
It's a complicated industry.
And regarding the mobile robots, so when you open a mobile robot, it's important to see that that mobile robot is designed and I mean to work as a mobile robot, because sometimes you open a mobile robot and you see, oh my God, this looks like like a fixed structure, no, right?
Mhm.
So when you open a mobile robot, you have to see that for example, plugs are used all around the mobile robot. If it is not working with plugs, I would worry, to be honest.
Absolutely. That's a really good point. So I think we're going to move on to questions in a second. I think to give Opteran's view, it seems like a technology is needed that cuts between the challenges of fixed infrastructure and the challenges of approaches like LiDAR SLAM and VSLAM. And that's what Opteran's building towards, something that uses low bill of material sensors, limited compute, easy setup time, flexible reconfiguration, and robust operation. As you said there, it needs to function well. And as one CEO of a famous AMR company once told me, SLAM breaks fails in very standard warehouse environments. And that is still a major challenge to move out of that innovation phase that you've been talking about. So before we move on to the Q&As, so everybody who's in the audience, it'd be great if you have any questions, any comments, please throw those into the chat. And while we're doing that, I think we're going to put the poll up again. Be great to see if anyone's changed their perspective based on this conversation. So, we can get to that one in a second. So, first question, I guess, for the panel, what advice would you give to companies just starting to implement mobile robots in warehouses?
Starting. Project management is key.
Project management.
No, from my side at least.
Dedicated team to best understand that installation. Walk hand in hand with the OEM that's installing that system, so you have a knowledge transfer that's happening organically during that. So you have a let's say a better educated team at the end user once the OEM leaves.
I'd start small, like before you go big and do it all, right? Build your own expertise. Like have your small team, have a dedicated team, and start in a scope and a size where you can actually which you can cope later on. But keep in mind to have it in a say with a real ROI, make a real project out of it. Because if you do a POC, like a classic POC, what you will get out of it is literally nothing. So if you have a real project, you'll see what will your total like your TCOs be, how will it evolve over time, and you will train your own team before you do the big thing.
Yeah. And treat it as a journey. You know, it's mile one of a marathon.
Yeah.
That's a really good point, Garret. So I think we're at the end of the call. There is one other question about Opteran, what our solution is, whether it's easy to implement. I swear we didn't plant that. Thank you, Mir, for asking. What I will say is if you're interested in hearing more from any of the panelists, please check out their websites. They've all got fantastic companies. And if you're building mobile robots, feel free to reach out to me directly on LinkedIn. We'll also be sending an email. And just to answer your question, Mir, Opteran has developed a mapping and localization solution that uses low-cost cameras only. It's not like SLAM, so it doesn't build a complex map of the environment, which means that we can set up very, very quickly. So it's actually a great theme that's been coming through because our system can essentially do single-shot mapping of no post-processing. But Mir, if you'd like to reach out, we'd love to talk to you in more detail. Any closing remarks from everyone?
Thank you very much for having us, Jack. Much appreciated.
Yeah, it has been a pleasure. It has been a pleasure.
A good discussion, yeah.
Yeah, thank you all.
To the next one.
Yeah, me too.
Yes.
Thanks all for joining. It's been really, really interesting. Some super useful insights there, which I think the audience is going to find very helpful. So thanks again for joining us. Thanks to the panelists and look forward to hearing from you all soon. All the best. Thanks again.
Thank you.
Bye-bye.
Thank you, guys.